Pythagorean theorem. This is page 11 and 12 of our Using Formulas note packets. Okay, so the Pythagorean theorem is named for a man named Pythagoras. I think we learned a little bit about him when we watched Donald Duck in Mathmagicland. So, the Pythagorean theorem is used to find the missing side of a right triangle. Now, just in case you've forgotten what a right triangle is, it's a triangle with one 90-degree angle. So a 90-degree angle is marked usually like this with a box in it, and that would be one corner of our triangle. Okay, to represent Pythagorean theorem in a formula form, we use the formula a squared plus b squared equals c squared. And a is one of the legs, doesn't matter which one, and b is also one of the legs, and then c is what we call the hypotenuse. So this is called a leg. It's adjacent to the right angle. Here's another leg that's also next to our right angle. And then our longest side is across from the right angle, and it is called the hypotenuse. So always make sure that you have that longest side, or hypotenuse, on the side of the formula that has that squared number by itself. Now this only works if we square the numbers. We can't just say, well, if they're all squared and we're just going to square root anyway, isn't it the same thing to just add them together? And no, it's not. For example, if I have a common right triangle called that's not quite exactly right, but called a 3, 4, 5 triangle. So we've got our right angle right here, so these are legs and this is hypotenuse. Does 3 plus 4 equal 5? No, it equals 7. So just adding the numbers together and having them equal the other number doesn't work. That doesn't even make sense to make a triangle. But if we take them and square them, 3 squared plus 4 squared equals 5 squared, we get 9 plus 16 equals 25. And 9 plus 16 does equal 25, so that actually works. So just be careful, because that's a common mistake I've seen with students, because I think they think squaring it doesn't do anything. Why not just add them and make it easier, right? But that squaring process has to happen. Okay, remember the hypotenuse? We just talked about this. Oops. Hypotenuse is always opposite the right angle. Alright, here's the steps we follow to do problems like this. We're going to start by squaring the numbers. So we might have two numbers and one variable. So we're going to square the numbers we have. It might be the legs, and we take 3 squared and 4 squared, or whatever the numbers are, and square them. And then we're either going to add or subtract. So we will add if we know the hypotenuse. Oh, wait, nope. Add if you don't know the hypotenuse, you're going to add. So you'll subtract if you do know the hypotenuse, because what that means is if you don't know the hypotenuse, my computer's lagging all of a sudden, if you don't know the hypotenuse, then, well, that was fun. Oh, it came back to me. Huh, we're still recording. Here we go. So if you don't know the hypotenuse, then that means you have the two legs. So you're going to square them and add them together. But if you do know the hypotenuse, that means you have a hypotenuse and one leg, so you need to find the other leg. So you have to work backwards in this equation a little bit by subtracting the leg from the hypotenuse, and before you do the last step, which is taking the square root of the answer. Because remember, everything in our formula is squared. So when we want to just get the length without it being squared, we have to square root it. Okay, let's look at some examples together. I had already done these in a class, but I'm going to go ahead and kind of start fresh with some of this just to make it easier to follow along. So maybe I won't erase all of that because it's going to let me redo. Because I just have the numbers and I won't have to recalculate them. Okay, so to find the hypotenuse, look at this triangle. We have the right angle. Across from the right angle is the hypotenuse, and that's where the variable x is. Next to the right angle, we have an 8.5 and an 8. Those are the two legs. So to find the hypotenuse, x, we're going to follow the instructions from the previous page on page 11. This is page 12. And we're going to square the numbers we have. That means multiply them times themselves. You can use a little squared button on a scientific calculator, or you can honestly just type them in to multiply them twice together. You're going to add them, and then the last step is to square root. So I've got 8.5 squared, so you can just use the little squared button in your calculator, and 8 squared. If you don't have the little squared button or you can't find it, you can either, so these are little steps for your calculator, use the x squared, or you can use this button that looks like a tent. It's called a caret, just a little upside down V, and then type in the 2 after that, and that will give you an exponent of 2. So these are our little calculator instructions. Only if you have a scientific calculator. If you don't have a scientific calculator, then you're going to have a hard time doing the square root, but you can at least multiply the numbers together. So it would be 8.5 times 8.5 plus 8 times 8. So that's what 8.5 squared means, is that we're multiplying those together twice. And then 8 squared means we're multiplying 8 together twice. So that gives us 72.25. I got that number from my calculator. And then 8 times 8 is 64. We add those two numbers together and we get 136. Now that number right there represents c squared. But we just want to find c, or x, right? Because it's called x in our picture. So x is the hypotenuse c. This thing we just found from the formula is c squared. So to find c, we actually have to square root that. So you'll need a scientific calculator to find a square root. Find that button, put it in, and you should get your value for c. So I always like to look at units. These were in meters, so this distance should also be meters. Let's do one more. To find a leg, we're going to square the numbers, but this time we subtract. We start with the bigger number and we subtract the smaller number. Then we square root. So this time we have the hypotenuse and one leg, and we need to find the other leg. So we take the hypotenuse, which is the bigger number, and we square it, right? Again, I've got the 12.3 times 12.3 showing what that square means. And then we are going to subtract, because we're finding a leg, 9.6, and then we square that, so we multiply that together. So when we square those numbers, we get these numbers. We subtract them because we're finding a leg. We were given the hypotenuse, so we have to go backwards. And then that would be the leg squared, right? That would be x squared. So in order to find x, we have to square root our x squared. And that gives us this answer here, 7.69. And of course, the units are always good to include. That would be in kilometers, since our original picture is in kilometers. So why don't you give these last two problems a try. Draw yourself some pictures if you need to. This number 3 is going to be adding because we're finding the hypotenuse. Number 4 is going to be subtracting because we're finding the leg. So I want you to give those a try on your own. And then check your answers. Number 3, your answer should be 15.4. And number 4, your answer should be 12.6. So just follow the same procedure we did on question 1 and 2 and see if you can get those answers. If not, send me an email and I will help you work through those as well. Make sure you actually show your work when you go through these problems for me. Thanks.